MS Ramaya University of Applied Sciences.
Hello students, let us discuss about Toolmaker's microscope. The aim of the experiment is to use tool room microscope for dimensional measurement. A toolmaker's microscope is an optical measurement tool that magnifies a sample surface features to allow measurement on a linear or circular scale. Toolmaker's microscope is used for measuring the dimension of small components. Tool angle, distances, etc. can be measured. A ray of light from a light source is reflected by a mirror through 90 degrees. It then passes through a transparent glass plate on which flat parts may be placed. A shadow image of the outline or counter of the workspaces passes through the objective of the optical head and is projected by a system of 3 prisms to a ground glass screen. Observations are made through an eyepiece. Measurements are made by means of cross lines engraved on the ground glass screen. The screen can be rotated through 360 degrees. The angle of rotation is read through an auxiliary eyepiece. Clean the workpiece to be measured. Switch on the microscope. Place the workpiece on the table. Focus the workpiece and get the magnified image. Measure the desired dimension and interpret. Limitations of the device. It is a fixed device. Intricate and internal dimensions are difficult to measure. Only flat parts can be measured using this device.
Hi students, the name of the experiment is Measurements using Toolmaker's Microscope. The aim of this experiment is to measure dimensions like length, angle using Toolmaker's Microscope. Now let us understand the different parts of a Toolmaker's Microscope. This is the eyepiece. It is having a magnification of 15x. This is the diopter adjustment ring. This is the angle knob. Scale, you can see. The least count of the scale is 1 degrees. This is the angle knob lock nut or clamp. This is the vernier scale. The least count of the scale is 6 minutes. This is the vernier locking nut or clamp. Focus knob. This is the optical tube. This is the objective lens. The magnification of this objective lens is 2x. This is the surface illuminator. This is the y-axis. The y-axis micrometer head is having a range of 0 to 25 mm and a least count of 0.005 mm or 5 micrometer. This is x-axis moment. The micrometer range is 0 to 25 mm and the least count is 0.005 mm or 5 micrometer. This is the XY stage. So the movements in the XY stage can be obtained by rotating the x-axis and the y-axis simultaneously or individually. The range of the x-axis is 150 by 150, that is the stage. The stage dimension is 150 by 150. The y-axis and x-axis can move 50 mm. This is the operational panel of the Toolmaker's microscope. It has the power switch, the contour illumination switch, the surface illumination switch, and a light control knob to adjust the brightness of the light. Now let us start the experiment and measure the dimensions of this given specimen. The first step in using the toolmaker's microscope is to switch on the power switch on the contour illuminator, switch on the surface illuminator. The next step is to place the component on the XY stage. After placing the specimen on the XY stage, next step is to look through the eyepiece and adjust the focusing knob so that one can see a clear object through the eyepiece. I am adjusting the knob so that I can get a clear image of the workpiece. I have got the clear image of the workpiece now. Next step is to use the diopter adjusting knob. The diopter adjusting knob to see through the crosshair. Adjust the diopter adjusting knob and make sure you are seeing a clear crosshair image through the eyepiece. Now we are measuring the depth of the groove. So before measuring the depth of the groove, one has to align the crosshairs to one of the corners of the groove. So I am aligning the crosshair to exactly match with the groove starting point. One can use the degree knob to adjust or align the crosshair to the groove starting point. Now let us adjust the crosshair to the starting point or the first point of the groove. I am moving my x-axis, I am moving the z-axis, y-axis. A little bit of fine tuning. Now once this is ready, I am going to record the reading on the micrometer head. Now the micrometer reading is 4.575 mm. This is the initial reading in the y-axis. Now I am moving the y-axis to the other end of the groove and then I will see the reading in the micrometer head. The difference between the initial and the final reading gives us the depth of the groove. I am moving the micrometer head in the y-axis. Now I have touched the other end of the groove. The crosshairs have touched the other end of the groove. Now I will record the micrometer head readings and find out the difference. Now the micrometer head is reading 6.575. So the difference is 2 mm. That is, the initial position of the micrometer head was 4.575 minus the final reading, which is 6.575, gives us the depth of the groove, which is 2.00 mm. So this is how one can find out the depth or the width of the given specimen. Next, we can measure the angle of the specimen. So for that, we are using two scales. One is the degree scale, here the degree scale which is moving now, and the minute scale or the minute vernier. These are the two scales one has to use to find out the angles. The least count of the angle scale is 1 degree. The least count of the vernier scale is 6 minutes. Now I am moving the x-axis y-axis for aligning one of the surfaces to the crosshair. Now this brings us to the end of this experiment. Similarly, one can measure the diameters, the angles, the profiles of external thread, templates, etc. using toolmaker's microscope. This is one of the versatile tools used by toolmakers in the shop floor.
At MSR UAS, we spark your imagination unlike any other.